In this problem, we're given several graphs of different colors. We're told that all of them are the form y equals ab to the x, so they're all exponential. The first question is which graph has the largest value of b? So to remind you what happens as b gets bigger, I wrote this up here that says every time x goes up by 1, this is what happens to y. So in the first two equations I've written, I've shown b getting bigger. Suppose b was 1.12 as opposed to 1.18. By now I hope that you know how to take a growth factor and change it into a percent change. So the fact that the growth factor is 1.12 means every time x increases by 1, y increases by 12%. In the second equation, since I changed the b to 1.18, every time x goes up by 1, y will increase by 18%. So the bigger the b value, the faster the growth. So all we have to do is look at the equations and say which one is growing fastest. Imagine this is a race. Who would eventually win? It's clear to me that the black line would eventually be higher than all of the other graphs. So I'm going to say which graph has the largest value of b. I'm going to select black. The next question is actually pretty tricky. Which graph has the smallest value of b? So to explain what's going on there, I picked a couple of b values smaller than 1, and I made b get smaller to see what would happen. So in the first case, notice I have b to be 0.90. But remember that this means that you're keeping 90%. If 0.90 is my growth factor, or sometimes I like to call it my multiplier, that means every time x goes up by 1, I'm going to be multiplying by 0.90, meaning I'm going to be keeping 90% of the value. Well, if you're keeping 90% of the value of something, that means it's going down 10% each time. So every time x increases by 1, y goes down by 10%. Let's make b smaller. Making b smaller you'd think would make the decay less, but it's actually the opposite. By making b 0.20, remember that b isn't how fast it's going down, it's how much you're keeping. So if b is 0.20, that means every time x goes up by 1, I'm maintaining 20% of the object's value. Well, keeping 20% of an object's value means that you're losing 80%. So if you compare these, as b got smaller from 0.9 to 0.2, rather than decreasing by 10% each time x goes up by 1, it's decreasing 80%. So as b gets smaller, the decay rate goes way up. So it's going to be sort of dying faster is what I like to say. So you need to look at the curves and pick out the ones that are decreasing. That would be the blue and the orange. I want the one that's decreasing faster. It'll be the one that has the smaller value of b. So if you look at it, blue and orange start out the same start value, but it's obvious to me that orange is lower, so it must be dying faster. So it's losing more of its value, which means keeping less, which means a smaller b value. So here I'm going to select orange. The last question asked, there's actually 3 of them, is actually the easiest one of all. It says which graph has the largest value of a? If you remember what a is what you get out when you plug in 0. It's the vertical intercept, often called the y-intercept. So it would be the graph that has the highest y-intercept. That's obviously the green right here. No one said that these are tick marks of 1, but if they were, all these graphs would have an a value of 1. This would have an a value of 2. Regardless of what the tick marks actually are, the green has the higher a value. So I'm going to select green. Oh, you can't even see it. Let me move down a little bit, and you can see it's green. Before the video started, I actually, because I'm in instructor mode, had showed the answer, and it's black, orange, and green, so these are correct.